first order, like degree 1, degree 2 equation derivatives we have discussed. So today onwards we will be starting with the theory part, ANN, artificial neural network. And what we will do is, so we will first understand the theory for 1, 2, 3 classes, and then another 2, 3 classes we will be implementing it using PyTorch. Okay, so let me share my screen. Yeah, already shared. So every step of coding is based on theory that we are discussing, like line by line, whatever we will discuss in the theory side, same thing we will be implementing in the coding. So if you are not clear in the theory, it is very difficult to understand the coding part. Unlike machine learning, scikit-learn, where we have 3-4 lines of code for model building and training, this is not the case. Here user need to decide everything, right? So how many layers will be there in each layer, how many hidden layers will be there, right? In each hidden layer, how many nodes will be there, what will be the optimization technique, what will be the cost function, everything we need to decide while coding. So please understand the theory very thoroughly, and if you have any doubt, please ask me. Okay, so what we have seen in last class, we have seen this derivatives, right? So we will be starting with the neural network. So the first thing is artificial neural network, right? So what is neural network? Deep learning and neural network. So deep learning is not neural network. Okay, neural network is one part, or maybe you can tell it is a subset, right? Deep learning is everything. It's not only neural network. Neural network is a part of deep learning. So the first kind of algorithm that we are going to discuss now is called ANN, artificial neural network. This is the base, like we are learning the alphabets of deep learning neural network right now. So once we have learned alphabet, the next, as I described you, right, this particular diagram, if you remember, small neural network, medium and complex. So we are learning about the base algorithm first, that is ABCD. Once we understand that, once we completed ANN, we'll be discussing about CNN, convolutional neural network. So CNN is built on top of ANN, right? So in CNN, ANN plus something will be there. ANN plus CNN, right? So similarly, if you understand CNN, CNN has, so in CNN, we have different variations that we will discuss. And after that, we have RNN. So every algorithm will be easier for you to understand if you understand ANN. This is the base, okay? So let's start with neural network. So before we jump into ANN, let us understand from where this concept came, right? This concept came from us. So we have neurons in our brain, right? We in our body we have neurons. So the if you see, this is a typical this is a structure of a neuron. So we have dendrites, we have neuron, and then we have action, right? So and again, many neurons are connected with each other. So if you see closely, there are inputs to this neuron, and then from this neuron output is coming, that is action, and then again another neuron is there. This is connected to another neuron, and we have so many neurons connected like this. So this is a very basic architecture of a neuron at very high level. So how our neuron works, right? How the neuron works in our body, based on that concept, neural network has been created. So it is not a new concept. So deep learning is not new, basically, especially neural network is not new. 200 years ago, like 1800 something, is till that time the research is going on, and the first algorithm in neural network was like 100 years before, right? It is older. It is not recently uh, somebody has created it, right? Now the question is, if it is so old, why it is not very famous, right? Now only it became famous. Why in past days, why it was not famous? So there were some drawbacks of neural network, right? The algorithm has some drawbacks, and nobody could find the solution for those drawbacks. And once the solution has been found by a person called Jeffrey Hilton, so he is the godfather of neural network. He is the godfather of uh, neural network because he found a solution for the problem. What is the problem? What is the solution? We'll be discussing in the next class. So next class, in the sense, once we complete some theory, you will understand what was the problem before, why neural network was not famous, and what is the solution, and how that solution really helped, right? And after we get that solution, neural network is very famous nowadays. Okay, so now this is a very basic theory side. Coming to the actual neuron, right? Actual neuron, this is called perceptron. So what is a perceptron? Perceptron is a single neuron architecture. So what is a perceptron? Perceptron is a single neuron. This is a perceptron, right? Perceptron is a single neuron. So perceptron is the basic building block. What is perceptron? Perceptron is the basic building block. Okay, so we'll discuss one by one. The first thing that we will discuss is how exactly a perceptron is looking like. What is the architecture, right? What is the architecture of perceptron? So the architecture of perceptron is very similar to the architecture of human neuron. So if you understand, there are dendrites which is connected to neuron, and then from neuron action is from neuron we have dendrites, and then we have neuron, right? And then we have action, right? So see this, dendrites, neuron, action. So very similar structure is how the perceptron is looking like. We have neuron, we have inputs, and then we have an output. Let us understand this with respect to a real-time example so that you can understand. So let's say I am predicting house price, okay? So this x1, x2, x3 are nothing but features, input value. Let's say I have three features. First is your square feet, okay? First is your square feet, so house square feet. Second is your number of rooms, number of bedrooms, right? Number of rooms. And the third feature is locality, in which particular location that house belongs to, and then we have price. Okay, the output is price. So this is my y. What is my y? This is my y. This is my x1, first input. This is my x2, second input. And this is my x3, third input. Now, whatever I am describing is only for one row. It is very important to understand, okay? Let us take one row from this data. Let's say we have 1 million rows where we have 4 columns. We have an Excel sheet where we have four major columns. One is your square feet. Second column is number of rooms. Third column is nothing but the locality, and based on square feet, number of room, and locality, I am predicting the price of the house. Okay, so this is my data. So take the first row. One row I will take from this data. Let's say the first row is 1000 square feet house. 1000 square feet house. It is a 2 BHK house. So number of rooms are 2, and locality is, let's say, Marathali, and the price of this house is 90 lakhs, right? 90. So this is my first row, first value. So if I have to feed this value to my neural network, my neuron or perceptron, single neuron is called perceptron. Single neuron is called perceptron. So if I have to feed this value to my neuron, how to feed? X1 is 1000. X1 is my 1000 square feet. Then input value 2 is my number of rooms, that is 2. And the third is locality, let's say Marathali. And something will happen within this. What will happen? We will see. So there are 3 input nodes. How the neuron is looking like? How many input node? Number of input node is equals to number of features available in the data. So I have 3 features, so I have 3 input node. Everything will be fed to this neural network. And then finally we have an output layer, Y. So what is Y? Y is my price. I am predicting the price. So this is how the structure is, right? Now you have so many questions like what is happening within this neuron and all. We will discuss in detail. So what we are discussing now is a single perceptron architecture we are discussing. In a single perceptron, we have 2 things. We have 3 things. One is your input layer. Input layer is nothing but single observation. This is a single observation. One row I have taken, right? So this is input layer, and then neuron, and then output layer. Input layer, neuron, output layer. That is the architecture. Input layer, we have each input layer have different nodes. Nodes are nothing but features. If I have 20 features, I will be having 20 nodes in the input layer. If I have 100 columns in my data set, I will have 100 nodes in the input layer, right? In the first input layer. Now, something is happening in the neuron. We will discuss what is happening. All the input layers are connected to the neuron. And then something is happening inside the neuron. And finally, one single output is coming, and that is called Y. That is my output layer. How many nodes are there in the output node? One node is there in the output node. One node, that is Y, right? One node is there in the output node. So this is how the structure of a single neuron is looking like. This is called perceptron. We will go First, we will understand the basic architecture. On top of that, we will build more complex architecture. So this is the architecture of a perceptron, single neuron. What is a perceptron? Perceptron is the single neuron. Now, the next question you will ask me is what is exactly happening in this neuron? Inside this neuron, what is happening? So if you are interested, so now we will go little deeper into the architecture. We'll go little deeper into the architecture. So if you again see the same architecture, that is a perceptron, what you will understand is in this particular perceptron, we have input layers, that is nothing but features, input 1, input 2, input 3. We have 3 features here, square feet, number of rooms, and we have locality, x1, x2, x3. And then there is a neuron. This is what happening within the neuron. So what is x1, x2, x3, x1, x2, x3 are the features. What is w1 plus b, w2 plus b, wm plus b, right? So what is that? So basically what I will do is each node, each column, I will assign a weight. So for example, let's say I have square feet column, right? I have square feet column, and the square feet into weight. So I will be assigning some weight, let's say 0.5, right? This is my W1. What is this? This is my W1 plus, right? So, okay. So then in the second case, I have number of rooms multiplied by some weight, 0.7. This is W2. And again, we have third is nothing but number of locality. Let's say locality multiplied by a weight. Let's say 0.9. This is W3, right? And then every step we have another constant called B. So like 0.9, right? This is 0.7, right? And let's say this is 0.6 and so on. Okay, 0.6 and so on. So if you see this, it's a line equation. So if you remember the regression, it is nothing but y equals to mx plus c, right? Y equals to mx plus c. So what we are doing, I will go slow, and you can ask me if you have any doubt. So what I'm doing, each feature, each node, I am multiplying it with a weight. and then I am adding a constant, right? So what I am doing here is, once I have three features, I will explain. I just started, I will repeat, no worries. So we will go slow. Advanced batch, every class is difficult, so we will go slow, and any step you need anything to be repeated, I will repeat, no worries. Okay. So the neuron, what is the architecture of the neuron? What exactly happening inside? That is what we are understanding. So we have inputs, three features, three input, three nodes. Each node, we will be multiplying each feature, each column with a weight and with a bias, W and B. In the second case, again, in the second column, W and B. In the third column, W and B. Right? So basically what is happening is, um, so, okay, let me erase, right? Let me erase everything. So if you see this here, okay, so to make it simple, let us remove this B, okay? B is there, but we will remove this. Later I will revisit. So we will go step by step. B is there, but it is a constant, right? W1 x1 plus W2 x2 plus W3 x3 plus B. B is a constant. For this moment we are ignoring it. Later again we will consider, okay? But for this moment I am ignoring it. So step number one is assign a weight. Assign a weight. Weight is nothing but a numerical value. Now you will ask me how I will get this weight. That is how, I mean, that is the objective of this neural network. We will have a cost function. We will optimize it. We will find the optimal weights. That's a different thing. But now you can assume that I know the weights. Okay, let somebody told me which all values I need to assign. So I know the weights. So three constant W1, W2, W3. So weights for n feature, we have n weights. For n feature, we have n weights, n column, n weights. Each column will be multiplied. The value of each column will be multiplied by a weight factor. Let's say 1000 square feet, that is x1. I will multiply 1000 square feet with W1. So what is W1? W1 is nothing but, let's say, for now I'm writing just W1. It can be any value, right? And then what is happening in the second case, in the second feature, number of rooms, let's say number of rooms are 2 multiplied by W2. And in the third case, what is the third parameter? That is number of bedroom and number of locality. Let's say I'm representing as Marathali, right? Marathali, I'm writing Marathali with respect to a number. Let's say I'm representing it with, let's say, some number. Let's say 1 represents Marathali, right? 1 multiplied by W3, right? The weight 3, right? And what is happening inside this neuron? This is the function, that is what we are applying inside the neuron. In the neuron, I am adding all of this, right? I'm adding all of this and passing it through a function f of something. So I'm passing all of this through a function called activation function. We will discuss what is this phi. What is this phi, we will discuss. But what is happening? I equals to 1 to m w I x I. That is what is happening within the neuron. I told you, right? Something is happening within the neuron, and then the output of this, it is output of that is nothing but your y. So this is w1 x1, w2 x2, w3 x3, right? w1 x1 plus w2 x2 plus w3 x3. Everything when we add, summation of everything, and then that addition when we pass through another function called activation function, I'm getting my output, that is my y. Let us take an example. Let's say in the first case, okay, let us take an example. Okay, so let us take the first case, my first row. If you remember the first row, 1000, and w1 is a weight. Okay, w1 is weight. So let's say in my case it is 0.3. For the first feature, the weight is 0.3. Now in the second case, I know you have doubts like from where I got these weights, how I will know 0.3. So we will discuss in detail. It will take 3-4 class for us to understand how we got W1, W2, W3. Okay. So initially now you assume that somebody told us the W value. Today's class, you assume that somebody told us the W values. Okay. It is a constant. Okay. It is a constant, or somebody has told us the W value. So basically what you will understand the architecture. We have feed forward and back propagation. So in feed for basically what we are doing is in the iteration 1, we will take random values of W1, W2, W3, right? And then using that formula, we will be predicting some value. Let's say we are predicting 80 lakhs and the real value is 90 lakh. So what is the error? Error is 10 lakhs, right? Error is 10 lakhs. And then based on this error, this is feed forward. In the feed forward, what I will do is I will assign random value of W1, W2, W3 in the iteration number 1, and I will predict something. The y value I will predict. The error is 10 lakh. From this error, I will go back and again change the weights. Let's say in the second iteration, I will assign W1. In the first iteration, I have used W1 0.1, W2 0.1, and W3 0.2. Okay. Let's say this is what I have assigned in the first iteration. In the second iteration, I will go back and again I will update random. It's hit and trial, no rules, right? In the second iteration, what I will do, W1 I will change to 0.3, and W2 I will change to 0.2, and W3 I will change to 0.3. Right, and again I will I'll run the algorithm. I will find why in the second iteration. Let's say I have predicted 85 lakhs. What I will have predicted? 85 lakhs. And what is the real value? 90 lakhs. What is the error in the second iteration? 5 lakhs. Is the error improved? Yes. In the first iteration, error was 10 lakh. In the second iteration, error is 5 lakh. So error is reduced. So okay, now again I will go back, feed forward. Again in the third iteration, I will update my weights. Again what I will do is I will try W1 0.4, W2 0.25, and W3, let's say something else. Let's say 0.5. And again I will check. Again I will check. In the third iteration, after changing these weights, let's say the error is 87 lakhs. 87 lakhs is what I'm predicting, and 90 lakhs is the actual. Again, the error is reduced. So I will keep doing this until the error equals to 0. Okay, or very close to 0 means I am predicting very close value to the real value. Till that time I will be keep updating, and finally I will get the up to date value or updated value for, or the optimal value, I will rather say the optimal value of W1, W2, W3, for which the error is minimum. This is at very high level we have discussed. We will discuss everything in detail whatever I have said, right? How to find W1, gradient descent, optimization, feed forward, back propagation, everything we will discuss in detail. But now in today's class, you need to assume that, let's say somebody has given me these values, okay, the optimal values, right? 0.4, 0.25, 0.5, the optimal values of W1, W2, W3, somebody has given me. Now how the neuron architecture is, I will multiply my square feet with 0.3, my number of room, let's say number of room with, let's say 0.25, right? And let's say locality is, let's say 1, and multiply by, let's say another factor W3, that is 0.5, right? And take a summation of everything, add, and then it's a numerical value. If you add and then if you multiply and then add, you will finally get something, right? Let's say I'm getting something, let's say what I'm getting is, let's say 1005 or something I'm getting. I'm just assuming, okay? And then this will go through a activation function, okay? Let's say finally after going through activation function, I'm predicting something 1005. That is my y value. That what I'm predicting. So what is activation function? We will discuss in detail. but this is the architecture. Now, in all of this, we have B also, not only W, we have another constant called B. So what I will do is this all plus B, I will also add B, right? And then whatever we are getting, finally that will pass through activation function, and then I will get my Y values. Okay, please hold on for 2-3 more minutes. You will understand when I go to the next neural network architecture. Okay, so what we are discussing right now. So W1, W2, W3 are constants or random values we are assigning, right? And why it is important, you will understand when I go to neural network architecture. Okay, so let me erase everything. Let me explain what we have discussed so far. We have discussed 3 things. Okay, first thing is what is a neuron. We have discussed what is a neuron. Okay, so the neuron is nothing but the basic building block. Like the neuron, human neuron has this kind of architecture. We have dendrites, neuron, and action. Now next thing we discussed is what is a neuron. Perceptron. Perceptron is single layer, only one layer will be there. And we have input layer, we have neuron, we have output layer. How the neuron is looking like? Input layer, neuron, output layer. Now what is input layer? Input layer is equals to number of columns available in our data. If I have 500 columns, there will be 500 nodes in input layer. If I have 1000 column, there will be 1000 nodes in my input layer. Each node represent here one independent feature. Okay, now what is happening inside this neuron? So it's some mathematical equation, some mathematical function we are applying. So what we are doing, each feature is multiplied by a weight vector. Each feature vector is multiplied by a weight vector. Summation of all of those plus B. B is another constant. W and B are constants that we are introducing. How to get W and B value, how they are helpful, why we are adding that, we will discuss later. But this is how the architecture is. We are multiplying a weight vector W1, W2, W3 with the feature vector. Input vector, input value. Let us take one row. 1000 is the house price, let's say square feet. Each value will be multiplied with a constant, that is W1 plus W2 x2 plus W3 x3 plus B. That is what is my final function I'm applying, and that will go through a activation function. And whatever is the output, that will be predicted in the output feature column or in the output node or the output layer. So this is input layer, this is neuron, and then we have a output layer. Okay, now so what is the function? So basically y hat. So what is y hat? Y hat is nothing but the final prediction. Y hat is the prediction. Let's say I'm predicting house price is 80 lakhs or 90 lakhs. How I am predicting? The final y is nothing but this particular function. Using this particular function, I'm predicting my y hat. So if you will tell me the W and B values, X value I already know, I can predict the Y value. For I equals to 1 to n means what? For each feature, let's say I have 3 feature. So I will have X1 W1 plus B1, X2 W2 plus B2, X3 W3 plus B3, right? So I will have this equation. If I have 10 feature, X1 W1 plus X2 W2 plus X3 W3 plus X4 W4 plus X5 W5 and so on, plus X10 W10 plus B1 B2 B3 B10. I will add everything, and then whatever is the final output, that is my Y, that is my prediction. This is how the basic neural network is looking like, the architecture of a basic neural network or a perceptron. This is the architecture of a perceptron. We will again revise this, we will again do this, but let us like again understand some more theory about it. So what is the history of perception? Sorry, not perception, perceptron. A perceptron was formed of neural network introduced in 1958. Perceptron is introduced in 1958. Okay, Now, the next thing that we will understand is this activation functions, right? So I told you two things. So before we go to multi-layer neural network, we will understand this. So entire this thing will be passed through activation function. So y hat is nothing but a function of, not here. So y hat, the final prediction is a function of everything. Whatever I found here, that I will pass to a function called activation function. Please wait for 2 more minutes. Let me explain activation function, but I will pause here. If you want to ask me any doubts, I can answer before I go to activation function. So this is not the final output of y hat. This everything will be passed through a activation function. You will understand very soon what is activation, what all are the different activation functions. And then whatever is the output, that is the final y hat. That is my final prediction, right? That is my final prediction. So if you see what is activation function, there are different kind of activation function. We will discuss some of them, right? The first kind of activation function is threshold function. Threshold. It's a very simple function, right? So if phi of x, the activation function is if phi of x is 1, if x is greater than 0 means, so y hat is positive. Y hat means what? W1 x1, right, plus W2 x2, right, and so on. If the final output after you multiply and add, let's say the final output is 90 lakh, it is predicting 90 lakh. If this value, if this is x, okay, this value is positive, if the final value is positive, it will predict 1. If the final value is negative, let's say I'm predicting something around minus 50 lakh as the final output, right, it is negative, right, then it will predict 0. It will predict 0. This is one activation function. Now you just remember the activation function. I will explain you which activation function is good at which particular location and which particular kind of data, and what is the intuition behind each and every activation function. Some of the activation function you will be using if you are doing a classification problem, some activation function if you are doing a regression problem. So there are different activation function for different purpose, right? So next activation function is sigmoid, but I will pause here before we jump into activation function. I will pause here in this particular structure. Is it clear the architecture of a neuron? Is it clear or any doubt? Architecture of a neuron. You will have two basic doubt. Except those doubts, if you have any other doubt, please tell me. The first doubt you will have is how I will find out W and B. We have to discuss 1-2 hours to understand. We have a method called gradient descent method optimization technique, right? So we will be using another algorithm to find out optimal value of W and B. So except that question, another question is what exactly happening in the activation function. So activation function will again take some 15-20 minutes. We will discuss activation function in detail. But apart from that, apart from these two doubts, do you have any other doubt? Is it clear? How to assign initial values of I? I in the sense? The weight, are you asking weight, Sunil? So like W1, W2, W3, weight values. How I will assign the weight values?
No, it's summation. Yeah, you are given summation above
Yeah,
n and down I is equal to 1. So
yeah.
what this I value will be denoting, whether every time it will be 1 or by default it is 1, or
No,
y
no, it's
hat
a
is equal to summation of I is equal to 1 above you have given n, right?
Oh, yeah. So who can answer? So he's asking, what is this I? Xi, Wi, I equals to 1 to n. Can you explain? So who can explain this?
This is the
Number of,
number of inputs.
yes. This is the number of inputs. Let's say, Sunil, you got an Excel file, okay, where you have 10 columns like square feet, basement quality, your first floor number of rooms, your build house quality type, locality, and so on. You have so many features. And then finally, there is a column called house price. You want to predict the house price. What will be the price of the house given all of these 10 columns to you? Okay, if somebody will tell you what is the square feet, how many number of rooms are present, how many like all the other details will give you, you have to predict the y, that is square feet. So xi is nothing but node. I equals to 1 to n. N is equals to number of features or columns available. If I have 10 columns, n equals to 10. If I have 500 columns, n equals to 500. So in this case, I have 3 columns. So n will be 3. I equals to 1 to n means for, so this equation I am generalizing. This above equation I am generalizing, right? So I equals to 1 means x1 w1 plus b1. I equals to 2 means second column x2 w2 b2. I equals to 3 means x3 w3 b3 and so on. Okay, is
Okay,
it clear,
got it.
Sunil?
Thank you.
Yeah,
Yeah,
no
got
problem.
clear. Thank you.
Yeah,
Hello. Hello.
yeah,
Ma'am, here that M and N is a different, I think. So that XM WM plus B, or here you are summation of I is equal to 1 to N. But
yeah,
in above, it's a
yeah, yeah.
printing is something else.
Yeah, I can replace it with n, but I think you can understand it, right? So m will be
No, no,
here, it is
I
going,
understand. Just for means not confusion, I'm asking this out.
yeah, sure, I will change it. So it is going till
Okay.
m here, it is going till n here, yeah. But you
Mhm.
understood, right? So this is the equation which I'm writing in this format. Okay, if I expand it, I equals to 1 to n xi wi plus bi. So this is what will look like. I equals to 1 1 2 2 3 3 4 4 till n I will replace, and then I will take a sum of everything like how I have done in the above equation. Okay,
Got it, got it, got it.
now the last thing that we will discuss is what is this phi. If you see this, so don't worry if you don't understand today. We have so many classes where we will be repeating. In tomorrow's class also it is the architecture. Today we have discussed about a single layer. We have input layer, we have output layer. There is nothing in between. Now tomorrow's class we will discuss about multi-level perceptron or neural network, basically the architecture of neural network. So we will have multiple layers. We have input layer, hidden layer and output layer, and we will repeat the same concept. So if you attend 2-3 classes, it will be very clear what we are doing. And also we will understand how exactly the neural network is learning. That is a separate topic. It will take 30 minutes to 1 hour to explain. We are understanding the architecture right now. Next question is how the neural network is learning, means how it is predicting y equals to 90 lakhs. If square feet is 1000 square feet, number of rooms are 2, and locality is Marathali, how the neural network is predicting 90 lakh, how it is learning, that we will discuss in a separate class. Okay, so today we are just discussing the architecture. So everything we discussed, this part is clear. Now what is this phi? What is this phi? Right? What is this function? So we will discuss that function now. Okay. So there are different activation function. You first understand what is that about, and then I will tell you why there are so many activation function and which one you need to use in which particular case. So the first activation function is a very simple function. The output, if you pass this activation function, can you tell me a question to you? The first activation function is threshold function. So if I'm using threshold function and I am passing this like I equals to 1 to n wi and xi, right? So the output of that, let's say it is coming something, let's say let's say 1005 when I multiply and add and everything. This I'm passing, let's say, through threshold function. Now, can anybody tell what will be the output? Let's say 1005. So what will be the output if I pass through threshold?
1.
1, right? If it is positive, it will predict 1. It will not predict 1005. It will predict 1. And if it is negative, let's say I'm predicting minus 1005 is the output, it will predict 0. So there are only two classes, 1 and 0. Every continuous value will be converted to 1, 0. Are you getting? Every continuous value that I'm predicting, if it is a positive value, then it is 1. If it is a negative value, then it will be 0. Now, can anybody guess? I think you don't have any background on the machine learning side, but we have a separate kind of problems called classification. In that case, we need only classes 1 and 0. I'll give you one example so that you can correlate, right? So here we are predicting house price. House price is a continuous number. So in this case, threshold function is not a good activation function to use. But let's say I am giving you one more example. Okay, let's say weather condition. You are predicting the weather forecasting. What project? Another project example I'm giving, that is called weather forecasting. You are working on a weather forecasting project, and in the weather forecasting project you have different kind of columns. Let's say the first column is your temperature, your atmosphere pressure, and so on, right? Temperature, pressure, and then weather condition. Based on temperature and pressure, you are trying to predict whether it will be rainy, it will be sunny, or it will be windy, right? And let's say in the first row, the weather temperature is, let's say 35 degrees centigrade, this thing, and let's say this column has some value, let's say 100, and then you're predicting rainy. So do you think in this, or let's say we have two weathers, rainy and sunny, okay? No, we don't have windy, rainy and sunny. Do you think the prediction here is a continuous value like house price? 90 lakh, 92 lakh, 93 lakh. Are you getting? So here the neural network, how many nodes will be there? Two nodes. One is temperature and one is precipitation, right? Or pressure or whatever. Temperature and precipitation or pressure. And then it will connected to the neuron, and then final output will be 1. So can you tell me the final output is in which format? Will it be a continuous value? 90, 95,000, 1 lakh, 1 crore, 2 crore, 3 crore, 1.2 crore, 1.25 crore, anything. The house price can be anything. It is a continuous numerical value. But here, what will be the neural network will predicting is not a continuous value. It will be either 0 or 1, right? 0 means, let's say, rainy season. 1 means, let's say, 1 denotes, let's say summer season, right? So it will be a class. It will be a class. If you are doing, this is called classification problem. The house price is called as a regression problem. In case of classification problem, this threshold activation function is good, right? You will understand more when we go to real-time projects. You'll understand more, but the objective here is convert every continuous number to a threshold. Apply a threshold to convert it either 0 or 1. There will be, but you tell me, if I have three classes, rainy, sunny, and windy, can I use this threshold as activation function? Question is, if I have three weather condition, rainy, windy, and sunny, the output can be sometime rainy, sometime sunny, and sometime windy. Can I use this threshold as an activation function? Can I use? No.
No.
Are you getting? Why not? Why I cannot use? Because I have only two options, 1 and 0. It cannot predict. It is not good for multi-class problem. It is not good for multi-class classification. It is good only when you have two class called binary class. Fraud, not fraud. Yes, no. Transaction, you will pay the loan, not pay the loan. Yes, no. The cell is a benign tumor or malignant tumor. The weather is rainy or sunny, right? So this yes, no kind of two classes. If you have only two classes, then only you will use this threshold as your activation function. Okay. So each activation function objective is different. So that's why I'm telling theory is very important, because if you do not know the theory, when you go to PyTorch and apply write your code for ANN, what activation function you will decide, because it's a user defined parameter. You don't know what activation function each activation function does, right? So you cannot apply randomly whatever you want. The output will be completely different. Okay, so you have to be very careful when you select activation function. This is one. Threshold. Is it clear? Threshold activation function. Is it clear? Clear, not clear? Okay. Okay, so now once we understand this, second activation function is sigmoid. Okay, so sigmoid activation function, the formula is 1 by 1 plus e to the power of minus x, where x is nothing but wixi. X is nothing but I equals to 1 to m. So now onwards, you always remember whenever I am saying x, x is nothing but this. You need to remember this. What is x? X is w summation of I equals to 1 to m wixi. Okay, so that is my x. So what I will do is whatever I'm getting, let's say 1005 I got, so 1 by 1 plus e to the power of minus x is nothing but 1005. So if I apply that, whatever I'm getting, right, whatever I'm getting, that is my sigmoid. So you go and check. Okay, you go and check. This is a sigmoid function. You know the function. You have a calculator at home. So try to find out the values for different x. For any random value of x, you try to apply this function. What you will observe is you will never get a value greater than 1. You will never get a value greater than 1. Always you will get a value between 0 to 1. So what this sigmoid function will do, this is a sigmoid structure, right? Everything that it will be, so whatever value you are passing through the sigmoid function, it will be squeezed between 0 to 1. The final output will be something between 0 to 1. It cannot exceed 1. Okay, the output will be something between 0 to 1. That is your sigmoid function. Now, where I will use sigmoid function for multi-class problem, I can use, right? Or for binary class also I can use. For example, let's say you have a image, okay? You have a image. Let's the first image is a dog, and the second image is a let's say the first image is a dog image, right? And the second image is a cat image. So you are building a classifier. Given this inputs, this we will actually, one of the small projects we will do when we go to next algorithm, CNN. So I'm passing this. So this is my dog or cat image. So this initial layer will be there, and then in the final output layer, it can be probability. So there is a dog and cat, right? So what is the probability? Let's say the final output layer has nothing but probability. So if I pass this image in the input layer, what is the probability of this image being a dog? Let's say the probability is 0.8. So as I told, whatever the output is, final output, when it passed with sigmoid, it will be 0 to 1, between 0 to 1. So if I'm getting 0.8, so it, the probability of having this image as a dog is 0.8. So the probability of not having this dog is 0.2, or the cat probability is 0.2, dog probability is 0.8. So it is a dog. The final prediction is dog. Let's say the probability at the final level I have predicted as 0.3. There is 30% chance that this particular image that you have passed in the input layer is a dog. So there is 70% chance that it is a cat. So I will predict it as a cat. So it is very similar to your threshold where we have 0 and 1, but it is, instead of directly telling you 0 or 1, sigmoid will give you a probability score between 0 to 1. So you will find a value between 0 to 1. Okay, so if there are 3-4 classes, I mean, more than one class you can predict using sigmoid. So you just understand the math. When we go to the theory, when we go to the practical section, I will tell you which activation function we will be using where. Anyway, all of this activation function, it is there in the syllabus. That's why we are learning. But we are using only one activation, that is Relu. If you understand that, no need to understand everything. These all are not that efficient. I'll tell you why. Okay, these all are outdated, so we are not using it. We have advanced activation function called Relu. We will discuss that. If you understand Relu, that is what we are going to use most of the time. Okay. There are some drawback with this activation, and because of this activation function, neural network was this is the problem with the neural network. I'll explain you next class. You will understand why this activation function. Okay, so now also I can tell you. So if you see this activation function, what you will find is all are degree 1. So you understood derivative yesterday, right? Derivative in tuition we have about derivative. So what is the derivative of degree 1 equation? What is the derivative? Constant, right? D by dA of 3a. What is the derivative? 3, right? So that is the problem. So you will not understand now. Later we will discuss. So if this is the problem with all of this activation function, today what you can remember is threshold function, sigmoid function, mostly we are not using because there is a problem in it. Okay, these are outdated. But sometimes in interview you may ask, you may get questions. So that's why we are learning. Clear? So sigmoid and threshold, where you will use for classification. Is it clear? Threshold will give you 0, 1. Sigmoid will give you something between 0 to 1. Okay. Now the third activation function is hyperbolic tangent function. Okay. Hyperbolic tangent function will give you output between -1 to +1. Hyperbolic tangent function will give you output between -1 to +1. So whatever value you are having x, that you will pass to this function. So what is this hyperbolic tangent function is tan h. What is tan h? Cos h divided sin h divided by cos h. So sin h is e to the power x plus. So I don't want to go so detailed. So you can remember the formula 1 minus e to the power of minus 2x divided by 1 plus e to the power of minus 2x. This is my tan h. Okay, hyperbolic tangent function. This is my tan h. Now the last thing is rectified. This I will explain you very detailed. Every step we will be using Relu and other activation functions. Who can explain me this function? This is a simple math. So you just see and explain me. This is very, very, very important. When we go for coding, we will be using Relu as our activation function most of the time. So who can explain what exactly it is doing? Yeah. Can you unmute and explain? Yes. So, okay. So you tell me what will be the value? 1005. What will be the final prediction if I pass 1005 to Relu as an activation function? What will be my final output?
1.
X is 1005.
Pardon?
Max of that value, 1005 would be the.
Yes. If it is 1005, prediction will be 1005. Let's say my prediction is I'm predicting 90 lakhs as the house price. What will be the output? X is 90 lakhs. What will be the output if I pass it through rectifier?
Yeah, 90 lakhs.
90 lakhs. Let's say my prediction is minus 35 lakhs. What will be the output?
0.
0. Now my prediction is 45 lakhs. What will be the output?
45.
Are you getting what it is doing? So
Yeah, max
who
of
can
the
explain?
max of the value that we returned.
Yeah, 0 and x means what? If whatever we are passing is negative or 0. Let me repeat. If the final prediction y is negative or 0, then it is predicting 0. Otherwise, it is not doing anything. Just whatever is the y value, wi, xi, summation of everything, that is what is my final output. It is linear. So till 0 or less than 0, everything is 0. It is predicting as 0. And so that makes sense, right? So in regression, right? What is the objective? So predict the house price. So if your house price final prediction, let's say 90 lakh. So final prediction will be any positive value will be passed as it is. We are not doing anything to the positive values. If it is 0 or less than 0, if I'm predicting negative, house price cannot be negative, right? House price cannot be negative. If I'm predicting something negative or 0, if I'm predicting, the output will be 0. Any negative or 0, output is 0. Anything which is greater than 0 is as it is. I'm not doing anything, just simply passing it. That is Relu. Can you tell me whether it is good for regression or classification? If I have a regression problem, then I will use Relu. Or if I have a classification problem, then I will use Relu. This is good for which kind of problem? Regression. Right? Because it is not at all good for classification. In wherever I want to predict continuous values, right? Wherever I want to predict continuous value, I have to use Relu, which is doing nothing actually, right? Relu function is nothing. So it is actually the same function. Wixi plus w2x2 plus w3x3 plus w1xn. I'm adding everything plus b1, b2. Whatever I'm getting, that is what I'm predicting. Okay, but if the final result is negative or 0, it will predict 0. Otherwise, whatever I am predicting is the final output. Activation function is not modifying anything. Okay, so that is really good for regression. Good for regression. But if you have classification, we will be using softmax or we will be using cross entropy. Later, I will explain you cross entropy. Or softmax we can use as your activation function. Okay, so why these activation functions are important, now only you can understand. As a user, no matter which library, deep learning library you are using, keras, pytorch, without understanding theory you cannot touch the programming. You will not understand anything, because every line you have to implement the theory. You have to decide which activation. Once you understood, okay, this is a regression, so I will be applying Relu here. If it is a classification, I will be applying softmax here, or I will be applying cross entropy activation, some other activation. I cannot apply rectifier in this case because this is a classification problem, right? So these are all concepts you will understand if you know detail about activation. So what I will do today, I will post a paper which is really nice paper. You will find 20 to 25. So if you go to Wikipedia, right now also you can go. If you go to Wikipedia, you'll find a list of so many activation function, but there is a paper also which describes it detailed way, so you can understand. See this, we have identity, binary. You can go through this. Okay, today it is, I just given you high level, but you can see how many different. We have rectifier, linear unit, Relu, we discussed about it, right? This is the function, right? We have Gaussian error, soft plus, exponential linear unit. Everything is a math function. The final output needs to pass through this, but we are not using all of this. I think Relu is mostly we are using. Leaky Relu, this is important. Relu we are using and Leaky Relu we are using. Now you tell me what is the difference between Leaky Relu and Relu. So if you see this, right? So can you see this is the function? So just try to understand. Okay, so Leaky Relu, here it is important. Sometime Relu, sometime Leaky Relu. So see this graph and you can understand the difference. Can you tell me the difference between Relu and Leaky Relu? Okay, so what exactly it is doing? So if you see, for x is less than 0, okay, let us understand what Relu is doing. If x is less than 0, what Relu is doing? You will definitely get one interview question for sure from activation function. Definitely one interview question. They will ask you because wanted to know your concept, whether you understood or not. So what is the difference? Okay, so the question is, if okay, sorry, I'm teaching and I'm forgetting the time. It is 7:35. I have another batch right now. Okay, but we will stop here. So what is the last question? Again, tomorrow we will continue with activation function. We have not finished. We'll continue. So what exactly? Yeah, 0. So if it is negative, we are predicting 0 in Relu. But in Leaky Relu, we are not predicting 0. If it is negative, we are predicting some value 0.01 into x. That is what we are predicting. Is it clear? In Relu, if it is negative, I am predicting 0. In Leaky Relu, if it is negative, I am not predicting 0. I am predicting 0.01 of x. Let's say 1005 is the final output. 0.01 I will multiply in 1001. Whatever is the output, that is what I will predict. Okay, and if it is x, same as whatever we have discussed in Relu. For positive value, there is no change. Leaky Relu and Relu both are passing the values. For negative cases, Relu is predicting 0, Leaky Relu is predicting 0.01 into x. Is it clear? Is it clear?
Yes.
And similarly with slide variation, you can see parametric rectifier linear unit. Remember all of this. I will be using in the coding. Okay. And what is parametric rectifier linear unit? This what it will do is alpha x, right? This is alpha x. There is a value constant. So everything is same if it is positive or 0. Relu, Leaky Relu, parametric rectifier linear unit, all are same if it is positive. If x is negative, Relu is predicting 0. Leaky Relu is predicting 0.01 into x. Always it is constant. And parametric is user defined parametric. So alpha can be controlled by user. It is constant here. Parametric means alpha is a constant but given by you. You can decide alpha. So alpha x. That is what you will predict if it is negative. Okay. So that is what this three activation function, very good for regression. Okay. And for classification, we have softmax and other activation functions. Okay, so we will discuss all of this thing in tomorrow's class. We'll continue. Okay, I'll pause here. So today your assignment is go and read about activation. I will upload one paper in the drive today. Very good paper, very nicely explained, some 10 to 15 activation function. Otherwise, if you don't want to go through, I think this is okay. This Wikipedia is also okay. You can go through this. Okay, everything is there: Gaussian, sigmoid, sinusoidal, everything. Okay. But read that paper, you will understand which activation function is good for which kind of problem, right? You will get a better idea. So I'll upload that paper as well. So what we discussed today is what is a neuron, very basic architecture about a neuron, and then neuron or perceptron, and then we have discussed about activation function. Okay, so neuron is nothing but WIXI plus BI. That particular output has passed through a activation function. Whatever we are getting, that is what I'm predicting. But this is just at very high level. We'll go and deep dive how we can find W, how we can find B value, how exactly neural network learns, right? We will discuss in next lectures. So the entire week, next week, Monday to Friday will be on ANN. Okay, we'll be discussing about mostly on ANN. So we have so many classes, theory as well as coding, both are important. Okay. Okay, so let's discuss tomorrow. Thank you all.
Thank you.
Thank you, ma'am.